I'm Saptarshi Mukherjee. I lead the product marketing function for our data analytics and IoT business areas. And today we have a really, really interesting topic. We're going to focus on the total economic impact of moving data analytics workloads to cloud. How do you evaluate some of the options? We will be joined by Mike Leon. He's a senior analyst from ESG Enterprise Strategy Group, and Sam King, who is an engineering manager from Nuna Health, and they're going to share some of their insights. So why did we choose this particular topic? Google Cloud is a fairly deep technical conference, but when we engage with customers, a lot of them, one of the common recurring theme that we hear from them, that we have the best technologies in our on-premise data centers or on Cloud X or Y. If we move to Google Cloud, how is it going to impact our cost or our total economic value? So it's important for us to understand that all data warehouses that are running in the cloud are not the same. All Hadoop or Spark workloads that could run on different clouds are not the same. So how do we essentially evaluate those options through some fine-grained parameters and come up with a TCO model that's long-term, that's going to give you a long-term value? So today we are going to talk about why economic impact in the cloud, especially for data analytics, matters. Some of the key considerations for evaluating the economic impact. And then we will take two use cases. One, moving data warehouses to the cloud. And we will talk about moving data warehouse to BigQuery as an example. And Mike is going to take us through the economic rationale and economic modeling for that. And then we are going to talk to Sam. They have actually moved their on-premise data management platform to Google Cloud. What were some of their decision criteria? What has been their experience so far? And then we're going to go to the next use case of talking Hadoop and Spark movement to cloud and how to evaluate the economic impact for that particular one, and then come to some conclusion. Hopefully it'll be a useful session for all of you. So with that, I'll first hand over the presentation to Mike to talk about why cloud matters and why data analytics. Mike.
Thanks, Sap. How's everybody doing? Exciting first day. So Enterprise Strategy Group is an analyst and strategy firm anchored in end-user market research and validation services. So we conduct annual research throughout the year across various segments within IT. And one of our most popular surveys is our IT spending intention survey. That's where we ask mid-market and enterprise class organizations where they're placing their bets. What are they spending their money on over the next 12 to 18 months? And within that survey, we track technology adoption, challenges, pain points, etc. And obviously, one of the major trends is around cloud. And this year, the survey showed that 85% of organizations are leveraging cloud computing services to some degree. Now, of course, there are three buckets of consuming cloud computing services. Software as a service is in the lead, but the big takeaway here is platform as a service is gaining traction. Organizations are starting to realize the benefits of being able to abstract the hardware and focus on the data and on the applications. So with that in mind, I'm sure many of you have already migrated to the cloud. We leveraged our research to understand what are some of the advantages of moving to the cloud. And this is general. This isn't specific to analytics. And far and away, it's cost savings, right? And of course, there's a bunch of other items that we can talk about. Here are the additional items: flexibility, accessibility, reliability, manageability, and whatnot. But the big thing to think about is all of these items can come back to cost. Accessibility, how's your cost or revenue impacted if there's downtime, if there's a failure with reliability? OpEx is a big thing that we're going to focus on. So now let's shift to use cases. Far and away, the major use case right now is lift and shift. With IaaS and PaaS consumers. The next use case on the list is leveraging public cloud computing services for analytics. So think data warehousing, data processing, BI, et cetera. And I found that really interesting. The reason it's interesting to me is this was a more popular use case than leveraging the cloud as a cold storage tier, as a backup target for archive, for DR. So I thought that was pretty impressive. And now let's talk a little about spend. What are mid-market and enterprise organizations spending on over the next 12 to 18 months? And the interesting piece here is there's an interesting marriage, I think, between these two items. So over 50% of organizations are going to spend more on cloud computing services. They're also going to spend more on data analytics solutions and becoming more data-driven. So when you put the two together, organizations aren't just going to take out their checkbooks and say, yeah, I need these things, everybody else is doing it, I need to remain competitive. They need to evaluate the costs. And when you're evaluating costs, especially going from on-prem to the cloud, you need to think about it a little differently. So I'm going to share with you what I think is a good high-level framework where you can start to map out how those costs differ, specifically when you're moving analytics from on-prem to the cloud. So the first bucket is really traditional CapEx. But to make it fair for the cloud, we have to account for if you're leveraging a cloud service where you're paying an upfront cost. So think of this as a cost that you have to pay before you're starting to realize value. So I bought the solution, but it's sitting idle. I'm still working on configuring, deploying, testing, et cetera. The next to really account for the fact that you're going to have monthly costs associated with consuming cloud resources, we have another category around just cloud costs. So month-to-month costs associated with storage, compute, streaming, ingest, et cetera. Now's where I think it gets a little interesting when we shift from CapEx to OpEx. And this is really where I feel the cloud shines. So when we bucketize OpEx, we do it in two ways. First, it's just traditional OpEx. So that's time and manpower spent dealing with deployment, configuration, procurement, et cetera. This isn't necessarily focused on the actual application or the data. That's what the next category is for, which is around the administration costs. So a good way to think about the administration cost, obviously I have it here around what you're doing on a daily basis, but it's really more about an IT administrator and the amount of time they spend responding to end users. So if you're an IT administrator and you're serving as a gatekeeper to some degree, the example here is around query orchestration. If you need to prevent end users from accessing the system in an unlimited way, there's a cost that's going to be associated with that. Finally, maybe the most straightforward here, maintenance costs. So think support, professional services, et cetera. So to boil it up, when we think TCO, it really requires a different frame of thinking when you're leveraging the cloud for data analytics. It's not just CapEx. If anything, it's really about understanding the OpEx behind it. So first and foremost, you're really overcoming those traditional cost burdens. You don't have to worry about configuration, deployment. You don't have to worry about over-provisioning resources if you're leveraging the right cloud platform. And simplicity is a big deal for a couple reasons. First, it's about empowering the IT generalist. You don't really have to worry about that skilled admin dedicating a ton of their time to deal with end-user requests when you're leveraging the cloud platform. And that simplicity extends to the business. If you have the right system that's easy to use, intuitive, you can really allow the business analyst to take matters into their own hands in a controlled environment. Right, we don't want to give them access to everything. And with that simplicity, it actually extends for the IT admin around cost transparency, visibility into what those end users are doing. And that's a pretty big deal, and it yields some pretty significant cost savings. Now, the first three items I talked about here, they're obviously clear positives for the cloud, right? Yeah, great, we're going to save a ton of money going to the cloud. There's going to be some additional costs you have to think about. One of those is if you're leveraging streaming applications. When you're not necessarily migrating in bulk, but when you're ingesting on a day-to-day basis or monthly basis, you're going to incur costs. The good news is that they make tools available to ensure that it's reliable, highly available, the workflows are sustainable, et cetera. So a lot of those items can be quantified. You can put a dollar value down that's associated with all those things. Where organizations tend not to look is around the opportunity cost. And there's a lot of angles to opportunity cost. What I'd say is there's so many organizations now that are data organizations, if not every organization is a data organization. They understand that data is their most valuable asset. They want to be more data-driven. They want to leverage a system that can respond to the business in real time or near real time. And they want to make sure that that system allows for end users and IT admins to do more for the organization. They want everybody focusing on the core business. With that in mind, if you're allowed or enabled by the platform you're using to let more end users, analysts, leverage a system to try and derive insight, you're going to increase collaboration across the entire organization. And that's a pretty big deal. So with that in mind, I'm going to shift back to Sap, who is going to talk about 2 use cases that he mentioned earlier. First, we're going to be chatting about BigQuery.
Yeah, absolutely. Thanks, Mike. So let's make it real. I think we talked about some of the frameworks. We talked to evaluate cost, both CapEx and OpEx. But we're going to look at 2 specific use cases. One is moving your data warehouse to BigQuery. Let's try to quantify some of these benefits. So how many of you are aware of what's BigQuery? Quick show of hands. Wow. We all love BigQuery. It's a great product. So BigQuery is Google Cloud's native data warehouse system. It's a serverless data warehouse that doesn't require you to pre-configure nodes and clusters or do capacity planning. You can get your data in, write SQL queries, get your answers. It's very simple. Let's keep it that way. There are a lot of benefits of BigQuery, like it's highly durable and encrypted, secure. It allows real-time streaming data analytics. But we will try to see how all of these benefits play a role in terms of the TCO. So this is BigQuery's architecture. So it's fundamentally different from traditional data warehouses in a way that BigQuery does decoupling of storage and compute. So what it means is when you get your data inside BigQuery, you can store your data in a replicated, highly distributed, and consistent storage system with very high reliability and durability. And when you fire a query to get an answer from your data, only then Google dynamically provisions compute infrastructure to query the data and get you the insights that you need. So your compute infrastructure, which is very, very costly, is not running all the time, unlike many other cloud-based data warehousing systems. And then there are other benefits that we're going to talk about in this context. So the first thing is in a traditional data warehouse, those of us who have operated in traditional data warehouse, you typically load your data overnight. Next day morning, you will get this management reports based on the historical data. You do a lot of BI and kind of descriptive analytics on top of your data. You use like traditional ETL tools. You have a DBA. The person is doing like defragmentation on disk, creating indexes, refactoring some of the storage systems. You need to kind of put in a lot of operations overhead to make your data warehouse responsive and keep the data warehouse like up and running. But BigQuery changes a lot of those traditional mold around data warehousing, right? So we have automated data delivery. Unlike traditional data warehouse, when you order a data warehouse on-premise, you get like an empty box, and you need to kind of spend 3 months to get the data warehouse up and running. In some of the other clouds also, what you get is a bunch of nodes and clusters, where in BigQuery, we have connectors for direct SaaS application like AdWords and YouTube, so you can immediately start getting data from those applications directly into BigQuery. BigQuery also lays the foundation for AI, not just BI. We do support a lot of BI and reporting on top of data stored in BigQuery with partner tools like Lookers and Tableaus of the world, and as well as with Google Data Studio. But we also support AI, and TensorFlow has direct connectivity. You will hear some of the newer announcements we're going to make in this area. BigQuery also supports real-time streaming data insights. So that means you can actually start streaming real-time data directly inside BigQuery and start populating the data warehouse with real-time data. And then a lot of data operations, like there's no concept of indexing or essentially taking backups, et cetera. It's all of those data operation steps have been automated. So if we have to translate all of this and quantify, so what? Like, does it impact my TCO? It does. And we actually had ESG, and then ESG actually conducted a study to understand if BigQuery is architecturally a very, very different data warehouse, how does it actually impact customers' TCO? So Mike, what were some of the findings?
Thanks, Sep. So as Sep mentioned, we conducted a 3-year TCO analysis, and we compared on-premises Hadoop and Amazon Redshift to Google BigQuery. And one of the things I want to call out, very important to call out, we looked at Amazon Redshift reserved instance pricing, and we compared it to BigQuery's on-demand pricing. And you're probably saying, well, wait a minute, that's not fair. And really, one of the reasons we did that is because when we were talking to some of the customers, it ended up that leveraging on-demand was more cost-effective for them than leveraging reserved instance. Now, I understand the predictability side of it, and that's fine, and everybody can have their views. But so we took that approach based on what we were hearing from customers. We leveraged end-user market research. We leveraged publicly available pricing, which is fantastic about the cloud. And then we did qualitative interviews with a number of Google BigQuery customers to understand where they were and where they are now. What kind of pain points did they have with their previous solution? And what benefits have they gained since leveraging BigQuery? And those customers came from Hadoop to BigQuery. They came from Redshift to BigQuery. They actually came from Redshift back to on-prem, back to BigQuery, which I thought was pretty interesting. So we took all that data and we created a model. And that model was spread across 3 different organizations that we just kind of threw out there as good starting points: small, medium, and large organization. Now, some of the considerations when you're looking at an enterprise data warehouse, we factored in number of data citizens, analysts that are actually doing the querying, how much data is stored, how much data is queried of the data that's stored, and then factored in streaming applications because you're going to incur additional costs. Now, I know these 3-year savings are pretty eye-popping. You don't really expect it. So I can't just show you the numbers. I've got to show you a little bit what goes behind the numbers, right? So we actually went into, I know this is an eye chart. This is one of many sheets, and this is really boiling it up. But the important takeaway is, the buckets I mentioned earlier. We started with those buckets, and then we added line items, one underneath, and started factoring in costs and taking all the information that was available and applying it to the 3 organizations that we were modeling. And one of the takeaways here is, while BigQuery provided savings or was at least equal to Redshift in a number of cases, where it really shined was on the OpEx side. So you can see here about I want to say 3 or 4 buckets down, you're going to see significant savings on BigQuery. So why is that? Well, BigQuery markets itself as a PaaS, and it is a PaaS. It's serverless. You don't have to worry about the infrastructure at all. That takes a massive amount of savings out from Redshift, which you still have to manage some of the infrastructure. Now, it's a perfectly fine solution, and that's fine, but when we look at costs, you really have to understand that you're going to be spending time spinning up instances and selecting instances and scaling up instances. So the infrastructure really is not abstracted. That abstraction has a major impact on savings. So again, looking back at the savings, and I'll leave it up there for a little longer this time, first and foremost, in the modeled organizations, and this is important to reiterate, that was for those 3 modeled organizations. There are going to be organizations that could potentially have larger savings. There could be organizations that may not have savings at all, and that's fair, and Google knows that. We know that. Everybody knows that. But first and foremost, going from on-prem to the cloud, you're going to save money. But what you're going to see here is the cloud provider that you select really matters. So if you're looking just at this medium-sized organization, great, I can save $300,000 going to Redshift. Well, I can save another $1.7 million over 3 years going to BigQuery for, again, this modeled organization. So the point here is, 1, you really need to understand your costs to accurately model your specific organization. So some of the takeaways from the validation, first on the infrastructure side, with BigQuery, you can leverage on-demand pricing, so there's no upfront investment, which is fantastic. And then you really don't have to worry about over-provisioning resources because they spin up automatically based on the demand of the query. Next, on the OpEx side, don't worry about sizing, don't worry about maintenance, really empowering that generalist to do more. And finally, cloud costs. A few things I want to talk about. First, simplified pricing. It's all publicly available. You can see it. They pay for storage, you pay for processed data, and then you pay for streaming. Now, obviously, that's for on-demand. Flat rate pricing is probably similar to reserved instance pricing. We can ask SAP later, but I believe that's true. You don't have to worry about scaling compute because it's done automatically. And finally, the last piece. How many people have had issues with interoperability when they're deploying a big data infrastructure? Anyone? Okay, cool. That would have been embarrassing if nobody raised their hand. But for the most part, Google handles the interoperability side of it in incorporating new technologies. So you pretty much keep leveraging the platform. You have no idea that you're actually leveraging the latest and greatest technology because they take care of the integration of that for you. So with that in mind, I'm going to hand it over to Sap and Sam's going to share some experiences he's had.
Thanks, Mike. That's really helpful insight, but let's make it real. So we have Sam King, and Sam is an engineering manager in Nuna Health. They're a startup based out of San Francisco. And do you want to quickly talk about Nuna, what you guys do, and then we can jump into the specific topic of moving data warehouse to BigQuery?
Yeah, so Nuna as a company tries to help folks understand health data so that they can make better decisions. Folks like the government with Medicare and Medicaid, as well as employer-sponsored health plans and insurance plans.
Great. And then you are dealing with a lot of data. Every company is, no exception, I'm sure. So before you moved to BigQuery, what was the on-premise system that you were using?
Yeah, so we pretty quickly made the decision that we wanted to be on the cloud, but our previous solution before we were on BigQuery, we started out with an open source distributed query engine, and this worked fine to start out with, but once we were scaling up, we started running into a lot of problems with it. Queries that used to take seconds started taking minutes. There were a lot of errors that we were encountering, even with pretty small queries. And also, in order to deal with a lot of that, we needed to over-provision the cluster, which resulted in a pretty high cost. And as a result, we knew that we would be able to fix those problems, but it would have taken a lot of time. So we started to look into different alternatives.
Okay. And then eventually you moved to BigQuery. So can you please take us through like what was your kind of decision-making criteria? What was the process that you kind of followed?
Yeah, so at Nuna, we're a data-driven company. We try to put a lot of discipline between all of the decisions that we make. And so for this one, we put together a spreadsheet. You can see a model of it up there. And you can see BigQuery is on the right. We also evaluated BigQuery against a bunch of other different solutions, including hosted ones as well as self-hosted solutions, similar to the status quo solution that we have on the far left there. On each of the rows, you can see a different thing that we care about. So you can see we really care about stability, and so that's weighted as a critical feature, and there are a bunch of other ones that are listed. And you might be wondering why we have some of these features in a talk about cost. And part of this is expanding the notion of what you think of as total cost of ownership. So when we talk about stability, for us, that really is a cost concern because if we miss our customer SLAs, then we're not getting paid. Same deal with things like operational experience. If we already know how to do something, then we don't need to invest time and the human cost there in order to learn about a new technology. And so we took all of these things that we care about, we weighted them, and then we filled out how good is each of these technologies in each of these categories. So you can see for our status quo solution, it actually rates good in terms of operational experience because we already have some experience using it. We knew what the problems were, whereas with overall stability, that rated poor because of all of the errors that we were talking about. The next thing that we did after we filled out a draft of this was reach out to a bunch of other folks throughout the company to get their opinion on this. So shared the spreadsheet. We got folks including the BI teams, including the CTO, including some non-technical folks in the company who primarily care about cost to comment on each of these weightings, on each of these values, so that the company as a whole could come to an agreement in terms of making this decision. And that was one of the most important parts of this process because initially there was a lot of resistance in the company to going multi-cloud, but because the decision process was so collaborative and transparent, we were able to get the buy-in that we needed. And you can see at the very bottom there are some scores. So we used the sidebar on the right, and we multiplied the weights by each of the values, summed it up to come to those scores, and then we did a proof of concept with BigQuery as well as hosted solution number 1. And when we did that, we found that BigQuery was even easier than we had predicted to prototype and to get running. So we switched over to using that.
Okay. And Nuna deals with a lot of healthcare data, right? You mentioned you were in the business of healthcare, so regulatory compliance and security, these are like important consideration. How do you evaluate those options in the cloud?
Yeah, absolutely. At Nuna, because we deal with healthcare data, we have a saying, every row of data is a life, and so privacy and security for that data is absolutely a top concern. And for us, one of the biggest features of BigQuery and Google Cloud Platform when we were making this decision was projects within Google Cloud Platform. So a project is basically full separation of all of the resources, including BigQuery as well as Google Cloud Storage and any other service that you use. And at Nuna, we care a lot about data separation because we need to keep each of our clients' data separate from one another. With our other cloud, we had to write a lot of custom code in order to achieve that, and that's pretty expensive to maintain because not only if there were a security breach would that be very costly, but the amount of time that it takes us to understand all of the multi-tenancy support that we've built in and just to develop those technologies are pretty significant. And so with BigQuery, we just use separate projects, and that works pretty transparently for us. And in addition to that, it helps improve the cost transparency and general the cost controls that we have.
Right. And what has been the experience thus far? You have been in BigQuery for a couple of years now.
Yeah, we've been using BigQuery for a little over a year, and so our experience has been very positive, both in terms of human costs as well as machine costs. We've seen cost reductions when moving to BigQuery. From the human cost perspective, if we had stayed with that open source technology, we would have needed to invest time in improving the scalability, reducing latency, reducing error rates, and improving multi-tenancy support. And each of those things would have taken multiple engineer months. And as a startup, we really didn't have that time, even if that were a good use of human time. And with BigQuery, on the other hand, it only took us a couple of weeks to build out the infrastructure and automation to switch over, and another couple of weeks to move over our SQL to the new dialect. And since then, it's been pretty hands-off. So from a human perspective, the costs have been much lower. And then from a machine perspective, it's been an even bigger win since, as Sap mentioned earlier, the separation between storage and compute on BigQuery has been big for us since we have a lot of data that we need to store, but that we don't query very often. And in addition to that, we have a lot of customers that need to have access to all of their data within a few seconds, but they might only query it once a week. And so because of that, we need to support very bursty query patterns. And BigQuery has been great about that. And the only way that we were able to support that with our open source solution was by dramatically over-provisioning the cluster. So switching to BigQuery has reduced the cost for us all around.
Great. Thanks for sharing the insights, Sam. Thanks for coming over. Really appreciate it. Thank you. So moving on, talking about the use case too, I think the neat summary from the BigQuery conversation is not all the data warehouses that are running in the cloud are the same. We need to be really careful to understand how those data warehouses are designed, how they are architected, how it's going to support your business, your very specific use case, your requirements to come to a TCO model. The second one is moving Hadoop and Spark to cloud. Again, how many of you are using some form of Hadoop or Spark for data processing? A lot of you. Great. We all love open source. Google Cloud is committed to innovate, and while we innovate, we are also embracing the best of the Apache open source project for data processing. Dataproc is a fully managed service that runs on our cloud for Apache Hadoop and Spark. We just announced the support for Apache Workflow, for Apache Airflow for workflow orchestrations. But let's talk about this particular use case. So this is a typical life cycle of Hadoop and Spark cluster implementation, right? So you first obtain the hardware server, configure the server, install the OSS, then go through multiple iteration of reconfiguration, optimization, debugging, and then finally process the data. It's a pretty labor-intensive process, and we are working with companies, really large planet-scale internet companies like Yahoo's of the world. Twitter just announced that they're going to move like thousands of Hadoop clusters to Google Cloud. We are working with disruptive startups who are like very leanly resourced but managing a huge amount of data. And then we are also working with large enterprise companies like the Home Depots of the world, the HSBCs of the world, and they are moving their big data processing workloads to Google Cloud. There is a reason behind it. So when we get to conversations with customers, and we typically ask, so you're using your Hadoop and Spark solutions on-premise or in some other cloud, what are some of the core challenges that you face? I think scaling is a major problem, like especially with spiky workloads, with a lot of seasonality involved, where the data volume could be unpredictable. Scaling often chokes customer down because they have pre-provisioned capacity, and expanding that, it's going to take a lot of time. Utilization, and this is the flip side of over-provisioning. Like if you have to provision for the most spiky workload, then you end up creating an underutilized infrastructure for you have to be accountable to your CFO. Hey, my resource utilization is less than 20%. Why should I keep continuing this in my data center? And then if you try to optimize either of these two, you encounter a lot of cost pain. Like if you keep changing your cluster configuration, you'll have to keep re-provisioning your hardware infrastructure. There's a lot of cost associated with it, like not only just hardware cost, but professional services that comes along with it. So what Google Cloud offers in this space is Dataproc, which is a fully managed Hadoop and Spark service that allows you to run like Hadoop and Spark jobs on our cloud. And Dataproc is an interesting service. So there are a couple of options for companies to run Hadoop and Spark jobs on Google Cloud. One is if you're running it on-premise, you pretty much do everything for running a data processing job. You write like custom code, you do like monitoring of the health of the cluster, scaling, job submission, connectivity, deployment, like everything pretty much. Then if you choose to move your Hadoop and Spark job as a VM option on GCE, Google Compute Engine in Google Cloud, you still do a bit of automation, like connectivity, deployment, creation. Those steps are taken care of by Google Cloud, but the rest of the thing you still have to do as a company. And then when you move to Dataproc, it's fully managed. So almost the only thing that you do is just writing custom codes. The rest of the things are taken care of by the platform. And by the way, small plugin, we're going to have a really interesting announcement around Dataproc on Wednesday. That's tomorrow. That I can't talk now. I wish I could. But we had ESG, and they came again just to prove the same point that not all Hadoop and Spark managed services that are running in the cloud are the same. So how is Dataproc different from some of the other alternates that are out in the market? And if a customer is already running it in on-premise, why should they even bother to move to cloud? So Mike, you want to share some of the insights from that research?
So when evaluating TCO for Hadoop Spark, there's a couple of obvious considerations, right? Node count. How many nodes are you going to have in a cluster? What are your resource requirements? What's your workload demand? Those are two pretty obvious costs. Now we start get to tricky areas. Daily runtime. Is your existing cluster running 24/7, or is there downtime? And if there's downtime, how much is it down? Are you running batch requests during the evening hours? Then during the day, you're allowing for ad hoc querying while you're doing batch at the same time. And with that in mind, the ad hoc querying starts factoring in that IT administration time. So is your IT administrator, or are you kind of a gatekeeper? Are you trying to prevent analysts from running ad hoc queries because they could potentially disrupt batch queries that are going on almost 24/7 to some degree. So you really have to factor in those costs, and you have to understand the types of runtimes that your environment's working with. And finally, burst requirements. Sap mentioned this. You have to plan for over-provisioning when you're on-prem. With a cloud, it's not necessarily something you have to think about because you can easily scale up, you can easily scale down. That elasticity that the cloud provides enables you to save costs when there is downtime. So we leveraged the same buckets as before, but we broke it down a little differently to account for Hadoop and Spark to some degree. And we broke out server and storage separate because it's decoupled. We also factored in infrastructure. Infrastructure here happens to be specifically associated with power, cooling, floor space, that kind of stuff. And then finally, administration and those cloud costs. So takeaway one, you're going to save money regardless of the cloud provider you use for the organization that we modeled here. Key takeaways, save up to 70% or more on the reduction in hardware. That's a big savings. OpEx side of things, you could save up to 85% going from on-prem to the cloud based on what we modeled here. And some of the key points around EMR versus Dataproc, in this case, you're going to see the similar areas of savings that we saw with BigQuery around administration, around cloud. It's not as drastic, I would say, as the BigQuery side, but you're still going to gain an economic advantage by leveraging BigQuery in this case. Now, the last piece I want to mention is at the bottom here. It's agility, and this goes to the opportunity costs. So when we were talking to customers and interviewing them as part of this study, these are quotes from 3 different customers across 3 different verticals, unrelated, that I thought was interesting, that, again, we can't quantify, but there's definitely a cost associated with it. So first is around being able to leverage a platform that will allow you to increase current revenue streams. If there's a business demand for something, you can easily access it in the cloud, and you can satisfy the requirements of that workload. Next is being able to capitalize on a new opportunity and being able to, again, leverage that scalable system that can instantaneously cater to your workload demands. And finally, the last piece, and I found this one interesting. I've heard this multiple times so far over the course of the last 2 days from customers who leverage not just Dataproc, but a number of GCP services. The ability to succeed, but more importantly, fail faster. And I want to go on this for just a second. If you're leveraging a cloud service and you're able to provide access to more people in your organization, you're going to obviously be able to gain insights faster. And with that in mind, you'll understand if you're going to be able to continue down the path of an initiative you have, or you can just stop and say, you know what, this isn't going to be successful, let's move on to the next one. That is something that this particular organization was able to do multiple times, and they really emphasized the fail faster. So with that in mind, I'm going to shift back to Sap, and he's going to highlight a couple of other customers that weren't part of our study to highlight a couple of other quantitative or qualitative savings.
Thanks, Mike. So just to kind of rephrase some of these concepts and make it real, we took 2 examples. One, a traditional enterprise, very traditional, but really great organization, Telegraph Group. They run one of the most popular newspapers in UK, more than 90 million subscribers. They were facing challenges to understand customer sentiment and do personalization because their existing systems that they had for their data warehouse were not able to scale for the type of analysis that they are trying to do. So what they did was they first tried another cloud-hosted Hadoop offering just to see like if they can offload that particular part of the workload and run there and continue to run their on-premise data warehouse system. It was just not scalable. The systems were not talking to each other. The cost was going through the roof. So they finally started doing a POC with BigQuery and then started using it. Now Telegraph Media is essentially analyzing more than 4 terabytes of data less than a minute. They minimize their cost per query. Look at how fine-grained some of these customers are going. They're essentially trying to track how many times the data warehouse is getting queried, what's the volume of data that is getting queried, what's the cost per query. And they are seeing cost per query saving. That's like the ultimate realization of the value from a data warehouse. And then it reduces their overall data analysis time from hours to minutes, and it's making the whole organization much more responsive. They're able to launch campaigns for their customers much more responsively rather than waiting for days or weeks for IT teams to get back to them with results. And then the other example that we took is a disruptive startup. So Ocado is one of the largest online retailers based out of UK, and they're redefining grocery experience through online web and mobile application. And Ocado, you can read about Ocado. There are multiple articles coming in Economist, like how they're disrupting the whole industry. They are one of our BigQuery customers, and Ocado is dealing with massive amount of data, hundreds of terabytes of data, and they had 2 concerns. One is like scale, because they are moving so fast, growing so fast. They wanted their data analytics infrastructure to support that growth. And the second thing is, while they grow and while they become responsive, they can't have like unprecedented cost exposure on their data analytics side. So they came to Google Cloud. They're not only just using BigQuery, but they're using a whole other set of tools, using Dataproc, GCS. And what they got is, one, query performance. It improved dramatically after moving to BigQuery, so faster time to insight. It increased their contact center efficiency. They're using not only just our data analytics stack, but machine learning to do labeling for emails, automatic responses back to their customers. And Mike talked about opportunity cost. Like, this is how the company is realizing opportunity cost, by reducing inventory churn, by being more responsive and reaching out to the customers on time, and saving lost sales. And you have to start quantifying those numbers by factoring in opportunity cost. So we talked a lot about different concepts and frameworks, gave you use cases. We had Nuna, we talked about customers. So how do you take it back home and start applying for your businesses? So a few things if you have to remember. I think I have to summarize. I mean, we are having a conversation right before this presentation. If I have to summarize this, we call it TLDR in Google, too long, do read. So basically, all that glitters is not gold. All the data warehouses that are running in the cloud were not designed for cloud. So if you are evaluating options, start thinking about a long-term horizon, not just what's the upfront cost of option A versus B. It could be a 1 year, 2 year, or 3 year horizon based on your cost appetite and exposure appetite. The second thing is go beyond CapEx. Just don't think about, okay, how much I have already invested, what's my sunk cost, what's my CapEx going to be, and how much my OpEx going to be. It's not a CapEx versus OpEx comparison. We need to factor in other costs. Build a framework. Nuna showed like how they went granular. They built a framework that was pretty exhaustive, that actually was designed for their specific business use case. So for your business, you have to build your own framework. Factor in business priorities. Scope in data growth, the amount of data that you have in your system, it's not going to remain the same over the course of next 2 or 3 years. And that's going to be the #1 blocker for you to grow. User consideration and usage pattern, like how many users are BI user, how many users are doing ad hoc analysis, how many of them are doing data science or machine learning workflows, and go granular. Specificity and granularity is very important in cost consideration. And then consider opportunity cost, like Ocado, for example, or the Telegraph Media. They're all thinking about how is my data management platform going to support my business vision and goal. And then compare cost with next viable options. Like, hey, BigQuery cost X amount of dollar, it's just not enough. If it is not BigQuery, if it is Redshift, or if it is my on-premise Hadoop system, what are some of the next viable options do you have? And then do a comparative study across those options, and then pick your best bet. So with that, I think we have come to the conclusion of this particular presentation. I hope you got something that's new. We refresh some of the memories for sure, like talking about BigQuery for those who are already using it, or Dataproc. We'll be here staying out to take questions and have conversations with you. I really want to thank Sam from Nuna and then Mike from ESG for their participation, and thank all of you for your presence here. Really appreciate it. Thank you.